Okay, this is going to be a video on for Algebra 2 for finding equations of transformations from graphs, also an applications problem. The big thing is when you make your graph, something to understand. Let's say you have a quadratic, okay, all right. Let's say we have something like this, okay. So to have an idea, okay, this number here represents being compressed or stretched vertically. Okay, this number here means stretched or compressed horizontally. Okay, this negative represents a reflection, and this will be either right or left. This will be up or down. Obviously, if it's right inside the function, you actually do the opposite, which would be, and same thing here. This is actually follows that. Okay, all right. So let's go through some examples. An absolute value equation stretched vertically by a factor of 7, translated 8 left and 3 down. Okay, so what that looks like, okay, all right, it's absolute value, okay, all right, stretched vertically by a factor of 7, all right, translated 8 left, so that's plus 8, so I have to put the opposite of where 8 would be. 3 down, I put the exact, okay, and that's the equation. Okay, a quadratic compressed vertically by a factor of 1/4, okay, so it's a quadratic, okay, so that's going to be x squared, compressed by a factor of 1/4, so 1/4 would go there, reflected, so that'd be negative, translated right 3, so opposite would be negative 3, and up 2. So that would be my equation. Okay. All right. I think that's the ones you try. Okay. All right. You're going to try those on your own. Okay. When you're done, go to the next page. All right. Now, when you're given the graph, okay. All right. What you want to do, okay. All right, is find sort of your starting point. Okay. So that starting point is 5, -7. Okay. That is a quadratic. So inside, we actually put the opposite. Outside, we put the exact, okay? Now, if it's flipped, you'd put a negative, okay? If it's not, you don't have to. Now, here's what you have to remember, and this may help you. If it is a quadratic, it is normally 0, 1, and 4, okay? Now, if you want to see if it has been, if it is compressed in any way, okay? 1, 1. So if I go 1 over, 1 up, I should hit the graph, which I do. So I do not have a number there. If there's a different number there, just change it and figure out what the multiple will be. Okay? All right, so that would be my one for that. This one is obviously an absolute value. Okay, this point right here is at -3, 1, 2, 3. That's -8. So inside I put +3, outside I put -8. Okay, now normally in absolute value, this is what I have, 1, 1 relationship. Now, if I go right 1, that's 1, 2, 3, 4, 5, that it would hit. So how can I go from 1 to 5? I'd have to multiply by 5. So that's why that is compressed by 5. Okay, and then if you went 2 over 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you would hit the other one. That's why that's a factor of 5, and you put a 5 there. Okay, let me make sure these aren't the big. All right, now this one, okay, all right, obviously is a quadratic. All right, that's at 0, 6, so I don't have to put anything in there. I got +6 on the outside, okay? Quadratic would be this, okay? Now, if I go 1 over 1, that's 1, 2 down, okay? So how would I get there? Multiply by -2, okay? So you can write it like that, or you could write it like this, okay? And that's how to find the equation. You'll have a worksheet in class to work on, okay? All right. All right, now for piecewise, okay, what you have to do is you have to find the equations, okay? All right, now, what you need is you need 2 points to make an equation. So this first one, all right, that is -2 over 1 up. This is -3 over 3 up. So I find the slope of that. Turn the wheel, 3, -3. Turn the wheel, 1 minus -2, okay? 3 minus 2, 3 minus 1 would be 2. -3 minus -2 would be -1. Excuse me, -2 is a slope. All right, I can use either point. Distribute that, that's -2x minus 4, and then add 1. That's y equals -2x minus 3. Okay, so that's what that equation would be, all right? Okay, all right. Now, this one here, I got a point of -2, 6, and I got a point of 3, 1. I could also find that one. Turn the wheel, 6, -2. Turn the wheel, 1, 3. That is 5, -5, which is -1. You can use either one that you want. You select either point. That's -1x plus 3. 1 minus that, add 1. I got y equals -1x plus 4. Okay, all right, that's that equation. Now, this one is a horizontal line. So when you have a horizontal line, that is a y equals based equation. Well, what's that y equaling at? It is -5, okay? Now that I've done that, it's sort of time to make the piecewise function. So I've got 3 equations. That first equation, okay, is y equals negative, see if I can put the answer down here. I got f of x equaling, that first equation was -2x plus 3. That second equation was -1x plus 4. And the last equation was -5, okay? Now, what you have to do is find where are those points starting at. So that is starting at -2, and it's going left, so it's x is less than -2. This is going between -2 and 3. Now, the reason why I don't put a line underneath that is because that's an open circle. This next one starts at 3, okay? So it's greater than 3, open circle. And that is my piecewise graph, okay? All right? So you gotta look at those and how that works. Okay, let's say we do this one, okay? All right, this first one right here is a horizontal. So that's gonna be a y equals equation. That's y equals -1, okay? This one, I'm gonna go from -4, -6 to 0, 2, all right? So turn the wheel, turn the wheel. That's -8 over -4, which is +2. Opposite, opposite, distribute, that's 2x plus 8. Okay, y equals, subtract 6, 2x plus 2. Okay, so that's the second equation, first and second. Last one is also a horizontal line. Okay, y equals, and that is at 3. Okay, so if I was putting the piecewise together, okay, I got y equals -1. Okay, now that's less than or equal to -4. All we care about is the x coordinate. This next one is 2x plus 2, and that is going to be between -4 and 2. And the last one is going to be 3, and that's going to be, oh, I'm sorry, not at 2, at 0. Well, that's not working. It's 0. This next one will be x is greater than 0. Okay? All right, I got one more. Now, this one doesn't clearly show the pieces, but I'm going to go ahead and put those pieces in. I'm going to put that as one of the pieces. Okay, now I'm gonna use this point as well. So that is negative 2, 2. That is negative 3, 3. Okay, so this line right here, if I turn the wheel, 3, negative 3, turn the wheel, 2, negative 2. Okay, that's 1 over negative 1, which is negative 1. Distribute, that's negative 1x minus 3. Okay, all right, so add 3, y equals negative 1x. Okay, this part right here is a horizontal line at y equals 2. So when I go to make this, okay, I got negative 1x. Now, that's going less than or equal to negative 2, okay? And then I got y is 2 for where x is greater than or equal to negative 2. Does not matter, okay, which one you use, because they end up being the same answer. And you're now going to try those piecewise ones on your worksheet. Okay, now we're going to go ahead and work on an application problem. All right, it says painters charge 20 per hour plus a $10 travel fee. Write a function expressing how money is made in terms of hours worked. So the concept of per, we sort of talked about this in the last unit. Okay, that's going to be your variable, your linear variable. So what I'm going to have is the money is then going to be 20x. All right, plus a travel fee of $100, okay? So that ends up being the answer for that. How much would the painters make if they have 18 hours, okay? So the concept is that I would put 15 in for x and do a calculation, all right? 20 times 15 is 300, plus 100 would be $400, okay? If they make $600, how many hours did they work? Well, the 600 would replace that part. So then I would just solve for x by subtracting 100. That's 500 equals 20x. And divide by 20. X is going to equal 25 hours. Okay? We did a very similar problem in the last unit. Okay? All right, and that's the one I want you to try based on that, okay? So whatever's per, okay, whatever's per, that's going to attach the variable, all right? So in that case, 20x, okay? All right? So then you can try this kind of problem on your own, all right? Now, this next one says, says the total tickets sold in the stadium since 2012 can be expressed by this function, okay? Assuming 2012 is the starting year, how many tickets will be sold by 2017, okay? All right, so the idea is what you have to figure out, if the starting year is 2012 and it's 2017, that's gonna be 5 years. So what I wanna do is I wanna put 5 in for x and do a calculation, all right? And then if you take out your calculator, you can do that, all right? 4 times 5 squared plus 170 times 5 plus 200. So that stadium would have sold 1,150 tickets, okay? By the year 2023, if you subtract 2023 from 2012, you would get 11. So then that's what I want to put into the function. Okay, so 4 times 11 squared plus 170 times 11 plus 200, that gives me 2,554. Okay, all right, and very similar question for you to practice on your own. Okay, and that is it for that lesson.